Hello students, today I am going to start with the revision of the first chapter gravitation. Today we are going to study about the gravitational potential energy. Before studying the gravitational potential energy, let us see what do you mean by potential energy. So you can see in the figure there is a two figures are shown. In the first figure the spring is tied to the one wooden block. Then now the without applying any force the wooden block will not be extended. So let us pull the block, we can say that D towards us. So when we pull the block, that time a force is applied on the block and we can say that the block get displaced one. You can see in the second figure the spring is displaced. So here because of applying force, we can say that the block get displaced. It means the work is done on the block. So this work is there is, we can say that the nothing but the energy stored in the block. Now when we leave that block, it will go towards its original position. The spring will try to attain its original position. So whatever energy was stored in the block, that is converted into kinetic energy, and because of kinetic energy the spring try to gain its original shape. So here without applying force, we can say that the spring goes to its original position. So the energy store because of its position, or we can say that the state is called as potential energy. Let us again see that one. The energy stored in an object because of its state or position is called potential energy. So in the previous that figure you have seen that the when the wooden is, we can say, pulled back, that time energy stored in it, and because of that potential energy the, we can say that it goes back, and it will, we can say that that energy is used to convert into kinetic energy. Now similar, we can say, the concept we'll use for the gravitational potential energy. First see the formula of the potential energy. So potential energy of an object of mass m at a distance or at a height h from the ground is mgh. Yes, if you want to find the potential energy of the object, then we have to take the mass multiply the gravity, that is the acceleration due to gravity of that particular planet, multiply the height to which the object is the raise. So by this formula we can find the potential energy. Now let us see about the gravitational potential energy. In the figure you can see the object is kept on the, we can say, the surface of the earth. Now this object we have to, we can say that take away from the surface of earth, and where we can say that the gravitational force is not there. Means you have to take the object away from the, we can say that this surface of the earth, so that at that place there is no gravitational force act on it. So you can see at infinite distance, if you take the, we can say that the object one, where the gravitational force does not act on the object, there we could say there is no, we can say, energy, no, we can say that any force acts on it. So at that place there is a, we can say, the potential energy is there, that will be the zero. And it means at infinite distance, if you take the object from the surface of earth, then that object has the, you can say, potential energy zero. It means if you take it back object 1, it gets some energy. Now this energy will be there, it will be less than 0, because at that place we can say that the energy is 0, and below the 0 always according to notation we can say the um, energy will be now negative. So here the potential energy, gravitational potential energy of the object will be we can say negative, and it is minus gmm upon r, or we can say whatever had we have taken r plus h. R means here the radius of the we can say the planet one, and that h, that is the height from that surface of earth at the height of the we can say infinite height we have taken the object one. So that h is taken consider as the we can say height at which the object is placed, so that the gravitational force will be 0. So like this, with the help of the formula, that is gravitational potential energy is equals to minus gmm upon r plus h, where g is gravitational constant, m is the mass of the planet, small m is the mass of that object, and r plus h is the distance of the object from the we can say center of the that particular planet one. In this way, we can find the gravitational potential energy. Now, let us see. Suppose the this object one you can see in the figure one. The when we are taking the object at infinite distance, that time work is done on the object, and because of that work is it is determined with the help of that gmm upon r. Same work is stored in the we can say the that object one, that is called the potential energy. Now this potential energy will be 0 at the infinite distance, but below that it is shown that its energy will be minus gmm upon r. So in this way we can get the negative gravitational potential energy. Now let us see about the escape velocity. Then in the escape velocity you can see in the figure, suppose the object is thrown we can say that the away from the surface of earth. So at one distance, what happen when we are giving the sufficient initial velocity to the that object one, that object will reach at a distance where there will be we can say that the no gravitational force acts on it, and at that distance we can say that the that object is now away from the gravitational force of the planet one. So the we can say velocity here, the velocity is given to that object so that the object goes to such a position where the gravitational force does not act on it, and here the velocity with which we are thrown that object one, that velocity is called as a escape velocity. So this velocity is sufficient for the object to overcome the gravitational force of the planet one, and it will we can say that the remain at the it can remain at the same place without we can say that the any moment one. So here the velocity is given to the object one, and it overcome the we can say that the gravitational force of the planet one, and it will remain rest at that position one. So escape velocity is nothing but the minimum initial velocity with which the object is able to overcome the downward pull of the planet one. Okay, here you are taken consider the earth, so you can say earth, and it can escape the earth forever, and that object will not we can say come back on the earth. So that velocity is there, it is called as a escape velocity. So we can find the we can say that if for object of mass m, the on the surface of earth kinetic energy is equals to half m ve square. Here escape, that is the ve means the velocity of the escape velocity we can say, and potential energy is minus gmm upon r. Here r is the radius of the we can say that earth one, and capital M is the mass of the earth, while capital G is the gravitational constant, and small g is the mass of the object. Then total energy is equals to kinetic energy plus potential energy. It comes half mve square minus gmm upon r. At infinite distance from the earth, the kinetic energy will be zero. Similarly, the potential energy also we can say zero. So total energy will be again we can say zero. Now, according to law of conservation of the energy, the E1 is equals to E2. Means whatever energy it has on the surface of Earth is equal to the we can say energy which is at the infinite distance. So half mv square minus gmm is equals to 0. After solving this, we get the VE is equals to under root 2 gr. If you put the value of that small g 9.8 and the r that is the radius of the earth that is 6.4 into 10 raised to 6, then on solving that we get the answer 11.2 kilometer per second. It means if the object is thrown with the velocity of 11.2 means minimum 11 velocity of 11.2 kilometer per second, means if it goes in 1 second minimum distance 11.2 kilometer, then we can say that the object can go away from the, so we can say that the gravitational force of the earth, and at that place we can say the object will remain at rest, and that whatever velocity we have given that 11.2 minimum, that energy that velocity is called as a escape velocity. So students, go to the video again and write the we can say that the homework which is display on the screen.